For any pharmaceutical company, it is very important to understand what is the review of their medicines when their medicines are getting used by the patients. So if they collect the information about their new medicines and how is the response of the patients, are those medicines actually solving their issues, then it would really help the pharmaceutical company to improve their medicines and come up with better combinations. Hi guys, my name is Rohit, and in today's video, we would build a classification model on the medicine review data, and let's see what kind of things we find in this particular data set. Let's get started. So here at the top, I'm importing all the modules that we need. So I'm importing pandas. Then from scikit-learn, I'm importing the matrix for the evaluation of classification model. So this model we are going to build using XGBoost Classifier. Then in this data, it's a text data. So I'm going to convert that text data into numbers using a TF-IDF vectorizer. And then we're also importing some other modules that we need for working on the text data. Okay, so I'm reading the data using read CSV function in pandas. This is the data we have. So in our data, basically we have two columns, a review column and a label. So if you see here, every row basically has a review of a medicine and a corresponding label. And the medicine can be of different category. It can be for depression, pain, anxiety, any kind of issue that a patient is facing. So let me show you some example of the review. Okay. So this is the first example, basically this one. So for this review, the label given by the patient is positive. So it's a positive experience patient is having. Now what is the review? I have taken antidepressants for a year with some improvement, but mostly moderate to severe side effects, which makes me go off them. I only take Cymbalta now mostly for pain. And what the person is saying? I noticed a major improvement overnight. More energy, better disposition, and no sinking to the low loads of major depression. Best thing, no side effects. So basically this patient is having a positive experience. So the label that we have for this particular review is positive. Then the next review that we have is this one. My genius psychiatrist started me on this drug in the fall of 2008. So basically, and what is the outcome basically? In retrospect, I wish I hadn't taken either fluoxetine or Seroquel. So basically, the patient is not having a positive experience on this particular drug or on this particular medicine. So the review or the label for this particular review is negative. So we have a negative label for this particular review. So this is the data we have. So we have information about the review of a customer and a label. Now, if you imagine if the company starts collecting the review of every patient, right? For them, it is very difficult to automatically understand which review is positive and which review is negative. So if they label just few thousand reviews and then if they train a machine learning model on that review data, then any new review that they would receive, they can automatically classify that review into a positive or a negative review and then accordingly take action on it, because the company would be very, very interested to know the negative reviews and what kind of side effects people are having after taking those medicines. So what we would do is we would take this review data and we would train a machine learning model which can automatically tell based on the review data whether this review is positive or negative. So in total, we have more than 12,000 reviews in the data that we have. So here, first of all, I'm reading the list of stop words. So the data that we have is in the English language. So I'm reading the list of English stop words and then all the punctuations. So we are going to exclude all these punctuations. So I'm just reading both the things over here. So this is the list of standard stop words within English. So the words like I, me, my, we, our, these words are not providing any specific information about the review. So these are the generic English words which we can see in all the reviews. So what we can do is we can remove those words from our text data. That's why I've saved all these words in a variable stop words. And then we would have to remove all the punctuations as well. So these are the punctuations which we are going to review from our data. So if we see any such punctuations, we are going to remove from that data in the data cleaning step. Okay. So I would explain you all these functions. So what I'm doing is, on the data frame that we have, I'm calling a text data cleaning function. So once I call this function, it would come here. So in the text data cleaning function, we are doing data cleaning step by step. So first of all, I am creating a new column with the name review original. And in that column, we are keeping our original review, so that after cleaning the text, we can still get to know what was our original review. So that's why I'm keeping that review over here. Then we are converting the data that we have into a lower text format. So in a lowercase format, using the str.lower functionality. Then after that, I'm applying a function for removing punctuations. So on the column review, I am applying a function for removing punctuation. So this remove punctuation function, what we have written in it. So basically what we are going to do is, we are going to remove the punctuations. So any punctuation which is present in this particular list, so anything from this would get removed from our data. Then we are removing the stopwords. So I'm calling a function for removing stopwords. So what's the logic written in this function? So this is the function for removing the stopwords. So what it would do is, it would basically split the text that we have, and it would take only those words which are not present in the stopword list. So basically, I am taking the word for every word present in our text after splitting that text, only if that word is not present in the stopword list, because we want all the words which are not stopwords. And then we are returning the data by joining all the words. So this is how we are removing the stopwords from the data that we have. Then after that, we are applying stemming. So we are calling a function for applying stemming. Now what's happening in the stemming? So here, first of all, we are initializing a stemmer. So I'm using a porter stemmer for that. And then this is the function for applying the stemming. So for every word that we have, we are going to apply a stemming. So stemmer dot stem, and then pass the word for which we want to get the stem version. So this we are going to do for every word in our review. So using the text.split, we are going to split our text into words, and then on every word, we are going to apply stemming. So stemming basically reduces the words to their base form. Then after that, we are also applying lemmatization. So lemmatization also reduces the words to the base form, but there are some words which we are not able to handle using stemming. So even, let's say, there are certain examples where it's a grammatical stemming, right? So that kind of thing, stemmer won't be able to handle, and that's where we need lemmatization. So lemmatization can reduce the words to the base form, even if they are not in the simple format. So for example, in stemming, if you get something like eating, it can reduce it to eat. But let's say if you get something like good, better, best, so that kind of format, stemmer is not able to understand. But lemmatizer understands that good, better, best explains the same thing. It's just a different way in which we are expressing the words. So that's why we are going to use a lemmatizer. So we are initializing the word net lemmatizer over here, and the same lemmatizer we are going to use for reducing the word to their lemmatized format. So here what I am doing is, lemmatizer actually needs the word, along with that a part of speech as an input. So by default, I am keeping part of speech as verb, because most of the words which we would reduce to their base form would be in the form of verbs. But if you want to improve it further, what you can do is, you can detect the part of speech of every word, and then accordingly you can pass the corresponding part of speech over here. So basically we are applying all the steps for cleaning the data. So we started with reducing the text to the lowercase format, then we removed all the punctuations, we removed all the stop words, and after that we applied stemming and lemmatization. So this would give us the cleaned data. So after applying the function, I am calling head df.head to check the first 5 rows of the data. So if you see here, now we have 3 columns: review column, label, and the review original. So this is our original review. And this column basically has the data of where we have cleaned review. So let's see how the cleaning is exactly happening. Example of it. So this is our first review, right? Where the patient is writing about the review of a depression related medicine. So this is the original data, and this is the data that we are getting after cleaning it. So if you see here, we have removed the punctuations basically. Then we have removed the stop words like I. If you see, depression is reduced to depress because we are applying stemming and lemmatization. Taken has been reduced to take. Then years has been reduced to year because stemming would reduce it to the base form. Then when we apply stemming and lemmatization, sometimes you might also get some weird words. So for example, improvement, it has reduced to improve. Okay. So these kind of weird words can also happen. But if you are going to apply, let's say TF-IDF vectorizer on this data to create a features, then it's not going to create any impact because all these improvements or any words which are improvement in your whole text data, all of them would get reduced to improve. So it's not going to create any impact on the quality of the results. But on top of this, if you are going to use any pre-trained word-to-vec model, then you have to be very, very careful while applying lemmatization and stemming. The label data that we have, I'm mapping a negative label to 0 and a positive label to 1 because we'll have to use it for training our machine learning model. So in the data that we have around 9,000 reviews which are positive reviews and around 3,000 reviews which are negative reviews. So on this data, I'm going to use TF-IDF feature extraction. So I'm keeping the first 10,000 reviews for training and the remaining reviews, so more than 2,000 reviews for the testing. So on this 10,000 reviews, we are going to train our machine learning model, and on the remaining data, we are going to test the model. So the first function that I am calling is TF-IDF features fit, and to this function, I am passing our training data. So this is the function basically. So in this function, I am initializing a TF-IDF vectorizer. So TF-IDF vectorizer is the one which would consider the frequency of occurrence of the words in the document in that particular review, as well as across all documents, across all the reviews. And based on that, it would convert every review text that we have into a numerical format. So I'm giving min def as 0.01. So the word has to be present in at least 1% document, and the max df as 0.1. So if any word is present in more than 10% document, we are going to remove it. This would help us in reducing really infrequent words and words which are occurring frequently across the document, because we want to focus on the important information. So here I have initialized the TF-IDF vectorizer, and after that what we are doing is we are applying fit transform on our training data that we are passing. So here I am passing only the training data. So on this I am applying a fit transform. So this would basically convert our text data into a numerical data into a TF-IDF matrix. And then I am just returning the TF-IDF vectorizer along with the feature matrix that we have. Then here I am getting the list of all the features using get feature names out. So this is the default method that you get within a TF-IDF vectorizer. So I'm using that to get the names of all features which we are creating using TF-IDF vectorizer. So these are the features which we are creating: 05 mg, 15 mg, then actual, addict, adjust, effect, bring, breakthrough. So basically every unique word in our document after doing data cleaning has been converted into a feature, and it would also have a weight which would be assigned based on the TF-IDF weight. So in our data, we are having 546 features. And this is how your feature matrix would look like. So here I am just checking the first row. So most of the features would have value 0 because TF-IDF feature would have value only when that word is present in that particular review. So here, for example, this word, it has TF-IDF weight 0.232. Then there is this another word which has TF-IDF weight 0.175. And most of the words which are not present in the document, they would have TF-IDF weight equal to 0. Then similarly, we are applying a transform on the test data. So I'm calling another function TF-IDF features transform. And to this function, I'm passing our TF-IDF vectorizer along with our test data. So if you check this function TF-IDF features transform, so we are applying basically a transform on the review data that we have from the test. So one thing that I want all of you to remember is whenever you are using a TF-IDF vectorizer, apply fit transform only on the training data, and on the test data, you should only apply transform function. This helps you to create a similar kind of an environment which is there when you deploy your model. Because in the deployed models, the reviews that we would get in future, your TF-IDF vectorizer, it won't be able to see it. That's why when you are testing the model, apply transform on test data and fit transform on the training data. This is very, very important, guys. Okay. So then I'm calling a train test split function. So we would have to split our data into train and test. Specifically, we would have to split data into features and labels. So this is the function that we have written. So here we are creating a variable yTrain, which would have the label information of the training data, and variable yTest, which would have a label information of the test data. So we have created a training and a test label. And similarly, I am creating xtrain and xtest, our training and test features from our training and test matrix that we got from TF-IDF vectorizer. So basically now we have converted the data in the form of numbers. We have a training data and test data. We can now go ahead and fit a machine learning model. Now you can use any machine learning model, but generally in the industry right now, XGBoost is the go-to machine learning model for most of the problem statements. So I'm calling fit and evaluate model function over here. And to this function, I'm passing our training data and testing data along with features and labels. So this is the function basically. So over here, I'm initializing a XGBoost classifier, and then we are fitting a model using fit function, which is a default function for XGB classifier. And to that function, I'm passing our training features and training labels. So this would basically fit the machine learning model, train our machine learning model on the data. Then using a predict function on test data. So I am now applying a predict function on the test data, and I'm using the same machine learning model which I have trained to predict the label on our test data. And after we do that, we can create bunch of evaluation matrix. So I'm getting a confusion matrix over here. So for confusion matrix, you will have to pass your original label along with the labels that you are getting after prediction. Then I also want to calculate the accuracy score. For that also, I am passing the original label along with the results that you are getting after prediction. These are the results basically. And then I'm also displaying the results. So I'm displaying our confusion matrix and accuracy score. And along with that, I'm also creating a classification report, which would give us complete idea of precision, recall, and F1 score across the classes. So this is how we have trained XGBoost classification model on our test data, on our training data. Then we have applied on our test data to create a prediction. And then we are creating a bunch of evaluation matrix. So one thing that I'm not doing over here is I'm not doing hyperparameter tuning. But for you guys, as a practice, what you can do is you can try hyperparameter tuning and see whether you get better results than the default parameters, which I am using. So this is the result that we are getting. So this is our confusion matrix. So, and the accuracy that we are getting in this case is 89%. So for class 0, which is our negative class, let me check whether class 0 is a negative class or a positive class. Yeah, so we have mapped negative to 0 and positive to 1. So class 0 is our negative class and class 1 is our positive class. So for class 0, for the negative class, the recall that we are getting is 0.65. It means that 65% of the negative reviews we are able to predict correctly that this review belongs to a negative review class. And this is happening because, see, the recall, if you see for class 1, it is 0.97. And overall F1 score for class 1 is 0.93 and for class 0 it is 0.74. The reason for this is most of the data that we have belongs to class 1. So again, to improve this result further, what you can do is you can give higher weight to the examples of class 0. So there is a class weight parameter within XGBoost classifier which you can use. Or you can do upsampling of the class 0 using something like SMOT, and that would also help you to improve the results further. So all these things you can try to improve this machine learning model. But even with the default parameters, we are able to get accuracy of 89% and F1 score of 0.74 for class 0 and 0.93 for class 1, which is not at all bad. Now with the XGBoost model, we can also get the important features. So I am calling a function get important features over here. And to this function, I am passing our model, which we have trained along with the list of features. So this is the function that I have written. So in this function, all the feature importances, I am storing them in the form of data frame. So from XGBoost, you can get all the feature importances using name of the model. So basically model is the variable in which I am storing our XGBoost model. So model dot feature importances. So this would give us all the features and their corresponding importance score. And I am just storing it in a better format. so that all the importances are in the ascending order, all the importances are in the descending order, so that we get the features with the highest importance at top. So after we do this, we would get a data frame like this. So here we have importance column and a feature column. So for every feature, we are getting what is the relative importance of that feature. So for example, feature worst, its importance is 0.021. Then feature worse, its importance is 0.019. Then horrible, vomit. So if you see, these all are negative words. So if people are facing issue after taking medicine, they are suffering. So these are all examples of negative words. So basically in this particular problem, any kind of a word which would help our machine learning model to separate a negative and a positive class, that word would come up as the important feature in this machine learning model. So these are the top 20 important features that we are getting. So if you see here, most of these are negative symptoms, like after taking the medicine, people are getting diarrhea, people are getting nausea. So all those kind of issues people are facing. And similarly, if I check the last 20 features, so features with the least importance, so there are some words like, let's say, case, real, enough, reason. If you see these words are not providing any information about whether it's a positive review or a negative review. That's why these words were not used by our XGBoost models. It was not used by the decision trees which are built behind the XGBoost model. That's why their importance is 0. So what you can do as a next step is you can remove all the features from the data now. Remove all the features from your machine learning model where you are getting feature importance equal to 0 and retrain your model. Because at the end, we want to create a model which uses only those features which are providing useful information. If these features are having 0 importance, it means that those features are not getting used in any decision tree. So there is no point in using those features again in terms of training as well as in terms of prediction. So we can remove those features from our data and retrain the model. Right. So if you see the results, so we are able to solve the problem statement that business had. We are able to now tell any review that we are getting from the customer, whether it is a positive review or a negative review, using the machine learning model that we have trained. So let's say that now the company starts a huge kind of exercise where they start collecting review from lakhs of customers, right? Then using this model, they can automatically know which reviews are positive and negative, and then start reading the negative reviews and start taking actions based on those. Right? And apart from this, whatever steps I have told you throughout this particular project, so I want all of you to try hyperparameter tuning. I want all of you to try class weight parameter for better data balance. Try SMOT as well. And also try to remove the features which are having 0 importance. Try these things and let me know in the comments what kind of results you are getting. Are you able to improve this model further? And let's see who comes up with the best model. Thanks for watching the video, guys, and I will see you in the next one. Bye-bye.